Hello friends, in this video we will learn about LVDT, strain gauge and accelerometer. So first let us see LVDT. So LVDT stands for linear variable differential transformer, that is LVDT. This is an electromechanical transducer that converts the linear motion of the object to which it is coupled mechanically in a corresponding electrical signal. Right? So LVDT, it is basically an electromechanical transducer. It converts linear motion into the corresponding electrical signals. The basic design consists of a cylindrical array with a primary winding centered between two identically wound secondary windings. The coils are wound on a hollow former. So let us see an example. This is constructionally the windings are wounded on a hollow cylinder. One side there is a primary winding, another side there are two secondary windings. So let us see here the primary coil A and the secondary coil B and C, which are connected in series. So the supply will be given, AC supply will be given to this primary winding and will get an induced EMF in the secondary winding. This is simply a transformer, as the name suggests. It is a transformer. As you may be knowing that the transformer, how it works. If the supply is given to the primary winding, then there will be EMF induced in the secondary winding. This is due to the primary winding produces magnetic field, and that magnetic field transferred to the secondary winding with the help of the magnetic core. So here the arrangement is different. Here windings are wounded, primary and secondary. The secondary is split up into two coils, coil B and coil C, and the core is movable. So this is called movable core in between these windings. So this is the construction. So how this LVDT constructed. The linear variable differential transducer is a common type of electromechanical high resolution contact based linear position transducer. So this is basically a linear position transducer. Right? LVDT is one of the best available, reliable and accurate methods for measuring linear distance. So it is convert position into electrical sensor. So now how it works? Whenever the AC supply is given to coil A, it produces the magnetic field, and in between the secondary coil B and C there is a movable core. So when this movable core move in between this space, so there will be a change in the EMF induced in coil B and C, and that will be measured here V2, and that is taken into the electronic circuitry for the signal conditioning, right? So there will be a difference between these two voltages that will be monitored at the output. So whatever the position change here, there will be change in the secondary voltage. So this is how it works. Now LVDT signal conditioning circuit. It consists of an additional filtering and amplification circuit where the absolute values of the two output signals are subtracted. So this is LVDT, primary secondary coil. So this, as I said, these both produces their voltages which are absolute value, and after filtering that values there is a comparator. It will compare both these values and it will take the output voltage signal. So this will be given to the electronic circuitry like Arduino also. So this is how the LVDT works. It senses the position with the help of this core and take the output signal to the electronic circuitry. Now where it is used? In various computerized manufacturing processes, manufacturing like automation industry, machine tools, the various machine tools, measuring tools also it can be used, where distance measurement is there, robotics purpose it is also used. Okay, now strain gauge. A strain gauge is a device used to measure strain on an object. The most common type of strain gauge consisting of an insulating flexible backing which supports a metallic foil pattern. So this is basically used to measure the strain on any object, and constructionally it is very simple. There is a flexible backing over there, and over this backing there is a metallic foil pattern like this pattern is fixed. So this is one electrode and this is second electrode, and in between these two electrodes this is a metallic foil pattern. So this is pasted on this flexible support or backing. The gauge is attached to the object by suitable adhesive. This total gauge is attached to any object where we have to measure a strain of that object. So it will be attached to that object with the help of suitable adhesive. As the object is deformed, the foil is deformed, causing its electrical resistance to change. So if that object deformed, this foil also deformed and causing that change the electrical resistance. Tension causes resistance increase and compression causes resistance decrease. If there is a tension on this metallic foil, so it will increase the resistance, and if there is a compression, so there will be resistance decreases. It converts force, pressure, tension, weight, etc. into a change in electrical resistance, which can then be measured. This resistance change usually measured using a Wheatstone bridge that is related to strain by the quantity known as the gauge factor. So this is what the Wheatstone bridge. This is quarter bridge strain gauge circuit. So R1, R2, R3, these are the three resistance, and fourth resistance is by this strain gauge. So as basically it is an electrical resistance changing device. So it will change the resistance according to the strain applied to this element. So it will change that resistance. So in normal condition, this circuit is as a Wheatstone bridge. So the voltage between these 2 points will be 0. As any change in this strain resistance increase or decrease, there will change in the voltage across this. So this voltage will be measured, and that signal will be given to electronic circuitry. So it will measure the strain. Now what is their formula for strain and gauge factor? L1 is the original length of wire and L2 is the new length after an external force is applied. So the strain is given by L2 minus L1 by L1. Now whenever an external force changes the physical parameter of an object, its electrical resistivity also changes. The strain gauge measures this deformity by using a gauge factor formula. So the gauge factor is the sensitivity coefficient of strain gauges and is given by this formula, gauge factor. So delta R, which is a change in the resistance, divided by Rg, resistance of the undeformed gauge, and E with the strain. So by using this formula we can calculate strain and gauge factor. So this is called strain. Now where the applications of this strain gauge? One is an aerospace, where the deformation in various aerospace elements we have to check with the help of strain gauge. It is possible. The cable bridges, the rail monitoring system also it is required. The torque measurement in rotating machine, load cells. So these are the application of strain gauge. So the next one is accelerometer. Use of this accelerometer to detect when something starts or stops moving. So accelerometer is available, 2-axis accelerometer, 3-axis accelerometer. So this is an example. We will study 3-axis accelerometer. So it will change this x-axis, this y-axis, and z-axis. So as this position of this axis will change, so it will change output voltage, and then we can use that output voltage for doing some useful work. So this is an example. So x, y, z axis, this is minus g, 1g, so x-axis, and this is for y-axis. So g, which is a unit for this accelerometer, so g means gravitational constant, 1g, minus 1g, 0g. If there is no acceleration, so it will be 0, then positive acceleration, then 1, minus negative acceleration, then minus. So this is the accelerometer axis, 2-axis or maybe 3-axis. Now principle of working. So this is the working principle for accelerometer. How it works? The capacitance accelerometer senses the change in capacitance between microstructure located next to the device. If an accelerative force moves one of these structure, the capacitance will change and the accelerometer will translate the capacitance to voltage for interpretation. So this is the internal structure of the accelerometer. There is a fixed plates, there is a spring, there is acceleration, MES accelerometer. So this is basically capacitance MES, that is micro electromechanical system accelerometer. So there will be a actual electromechanical system. So this will move as we move the position of this accelerometer. We'll tilt it, then there will be the change in this capacitance, and due to that change in capacitance, output voltage will change. That is called micro electromechanical system accelerometer. So with the help of these springs, it will again comes to its rest position. So it will change the capacitance, and due to that capacitance, the output voltage will change. So this is the principle of this accelerometer. Now the block diagram for this accelerometer. So this is an example of typical ADXL 335. This is 3-axis, popular 3-axis accelerometer having 3 outputs X, Y, Z. Reading from X, Y, Z axis reflects an orientation of an accelerometer. So plus 3 volts it is required. Then 3-axis sensor, then AC amplifier, then demodulation. In demodulation it will again split up into 3-axis, then output amplification, X, Y, Z axis, X output, Y output and Z output. So with respect to this resistance and capacitance, it will give this output X, Y and Z 3-axis. So whatever the axis we change here, so it will change that particular readings. So we can connect this accelerometer to Arduino, and with the help of LCD we can get that reading of XYZ axis on that LCD panel. So this is called 3-axis accelerometer. So it will look like this electronic circuit. So this is the main IC. So XYZ it is given here also. There are 5 pins, the voltage, ground and 3 axis XYZ. So this we have to connect to the Arduino or any microcontroller to measure the axis rotation. Now where it is used? In the cost sensitive low power motion accelerometer with the tilt sensing applications. So particularly used in mobile devices. So various mobile devices we often there are many functions available in smartphone. So that with the help of this accelerometer it is possible. For example, if you tilt your mobile, it will open the torch. This is an example. Gaming system, various gaming system it is used. Disk drive protection, it can be used here. Image stabilization also, and sports and health services also it can be used. So this is called an accelerometer. Okay friends, so in this video we have seen the LVDT sensor, strain gauge and accelerometer. So hope you understand. Thank you for watching this.